3-6, equations and solving, problem solving, part 2. This is the section where we work on uniform motion problems. This is based on the formula distance equals rate times time, where d equals distance, r equals rate, and t equals time. In the formula distance equals rate times time, I could solve this formula for any variable I wanted. For example, distance equals rate times time. If I wanted to solve this for rate, I'll divide by time. So rate equals distance divided by time. Same formula, distance equals rate times time. If I decided I wanted to solve this for time, I'll divide by rate. So distance divided by rate equals time. So I have 3 different formulas here. They're basically all doing the same thing. They're just different variations of the same formula. And we will use them interchangeably throughout this lesson. All right, let's look at solving some distance rate time problems. Distance rate time problems work best if you set up what we call a distance rate time table. That means you're going to put a little table on here where you're going to have distance, rate, and time, and you're going to fill in all the missing pieces based upon what you know. All right, so here's my distance rate time table. Bud takes a leisurely stroll. Okay, so we have Bud, he's the first person we're going to talk about. And then Carrie is our second person, C-A-R-R-E. There we go. So Bud takes a leisurely stroll. He walks at a constant rate of 2 miles per hour. Carrie starts out for a brisk walk 1 hour later. She walks at a constant rate of 3 miles per hour. How long will it take Carrie to catch up with Bud? Well, let's take a look at this. Okay. Distance equals rate times time. How fast is Bud walking? He's walking at 2 miles per hour, so we'll put a 2 in here for his rate. Carrie walks at a brisk 3 miles per hour, so she gets a 3 for her rate. Do we know how long Bud was walking? No, because it's asking us how long it will take for Carrie to catch up with Bud. So, since it's going to ask for how long, t is going to equal the time. Okay, it's going to be the time for Bud. Now, no matter what Bud's time is, Carrie started an hour later than Bud did. So when they catch up to each other, Carrie will have been walking for 1 hour less. So t minus 1 is going to equal Carrie's time. So we can fit those into our table. Bud's time is t, Carrie's time is t minus 1. And you might say, well, I don't know anything about the distances. Well, we do know this. If Bud is going to walk, he starts here and starts walking, and Carrie's going to walk a little faster. Eventually, when they catch up to each other, they've both traveled the same distance. It doesn't matter. Bud's distance and Carrie's distance are going to be the same because they're going to catch up with each other. So, the distances traveled are equal. Since the distances traveled are equal, move this up just a little bit. Okay. Distances are equal. So, and distance equals rate times time. Remember that. Distance equals rate times time. So Bud's distance, which is rate times time, 2t, has to equal Carrie's distance, because the distances are equal. So Bud's distance has to equal Carrie's distance. And distance equals rate times time, rate here, time there. So Bud's distance equals Carrie's distance, so there's our equation. Now we simply need to solve this. So 2t equals, don't forget to distribute, 3t minus 3. I'm going to move the 3t over, so I'll subtract 3t from both sides. And I will get negative t equals negative 3, but I don't want negative time. Multiply both sides of the equation by negative 1, I get t equals 3. If you remember, t is the time for Bud. What did the question ask us? How long will it take Carrie to catch up to Bud? So we're not going to say it'll take her 3 hours because she went 1 less hour than Bud did. So it will take t minus 1, so 3 minus 1 equals 2, so it will take Carrie 2 hours. That's a distance rate time problem in which the distances are equal. I'm going to go through several examples, and they're going to be slightly different each time, So you need to take down all the examples. Question 2. A group of campers and one group leader left the campsite in a canoe. They traveled at an average rate of 10 kilometers per hour. 2 hours later, the other group leader left the campsite in a motorboat. He traveled at an average rate of 22 kilometers per hour. How long after the canoe left the campsite did the motorboat catch up to it? And how long did the motorboat travel? So they're asking us 2 questions here. We need to make sure we answer both of them. So we need to make a distance, rate, time chart. We have people leaving in a canoe. And we have people leaving in a motorboat. Okay, so we have distance, rate, time. And it's asking us for how long after the canoe left the campsite did the motorboat catch up to it, and how long did the motorboat travel? So it's asking us for 2 things. So we should look at this question with that in mind, that we're being asked to find 2 separate things here. Okay, so a group of campers and one group leader left the campsite in a canoe. They traveled at an average rate of 10 kilometers per hour. Okay, do we know how long they traveled? No, we don't. So I'm going to let T equal their time. So T is going to be the time for the canoe. It says 2 hours later, the other group leader left the campsite in a motorboat. So the motorboat's time is going to be T minus 2 because they left 2 hours later. So no matter what, they're always going to be traveling 2 hours less. So T minus 2 equals the motorboat's time. At an average rate of 22 kilometers per hour. Again, the distances are equal because the boat's going to catch up to the canoe sooner or later. So if the canoe travels 10 miles, the boat to catch up to the canoe also has to travel 10 miles. So the distances are equal. And since distances are equal, distance equals distance, and distance equals rate times time. So the canoe's rate times the canoe's time has to equal the motorboat's rate times the motorboat's time. So distance equals rate times time. So rate times time equals rate times time. If we were to simplify this, 10t equals 22t minus 44. Subtract 22t from both sides. I'm going to have negative 12t equals negative 44. Divide by negative 12. Okay, use my handy dandy calculator. T is going to equal a big ugly decimal. We don't like big ugly decimals because they're not exact. Right? T equals 3.6 repeating. I don't want that as an answer. 0.6 repeating, if you do not know, is 2/3. You should know that by now. And if you don't, I just told it to you. So the time here is 3 2/3 hours. And that's the time for which one of these? If you look at it, T is the time for the canoe. So the canoe's time is 3 2/3 hours. To find the motorboat's time, we subtract 2 from that. So 3 2/3 minus 2 is 1 2/3. And the motorboat's time is 1 2/3 hours. Because 3 2/3 minus 2 is equal to 1 2/3. So there's the canoe's time and the motorboat's time. Problem number 3. 2 cars leave town at the same time in opposite directions. This one's slightly different. One travels 35 kilometers per hour, the other 40 kilometers per hour. How many hours will they be 200 kilometers apart? Okay, so again, we've got 2 cars. Let's just call them car 1 and car 2. Makes it easy. We're still going to be doing distance, a rate, and a time. Alright, 2 cars leave town at the same time. So car 1's going this way, car 2's going this way. Eventually, they have to be 200 kilometers apart. They're driving away from each other, so eventually they'll be 200 kilometers apart. One travels at 35, so let's make the car 1 be at 35. The other one travels at 40. They both leave at the same time, so T is going to be the same for both of them because they're going to both be 200 kilometers apart at the same time as well. So T is going to equal the time for both cars. The distance is 200 kilometers. So together, the distances they have to travel, distance for car 1 plus the distance for car 2 has to equal 200. So I'm just going to put a 200 across both of these because together they both have to travel 200 kilometers. So the distance for car 1, distance for 1 plus the distance for 2 has to equal 200 kilometers. Remember, distance equals rate times time. So the distance for car 1, the rate times the time, plus the distance for car 2, the rate times the time, has to equal the total distance they'll be apart, which is 200 kilometers per hour. So 35t plus 40t has to equal 200. Add those together, 75t has to equal 200. Divide by 75. 200 divided by 75 is, again, a decimal that doesn't terminate. It's 0.6 again, so it's 2.6 repeating, which is 2 2/3 hours. And it asked, how many hours will they be 200 kilometers apart? They will be 200 kilometers apart, 2 2/3 hours. That's the answer to that problem. Slightly different than the first two. Let's look at problem number 4. This one's going to be different yet. On his way to work from home, your uncle averages only 20 miles per hour. On his way home, he averages 40 miles per hour. More traffic in the morning than in the evening, I guess. If the total time was 1.5 hours, how long did it take him to drive to work? Okay, so we went to work and home. So, to work and home. Or from work, you can do it that way too. Distance, rate, time. Okay, on his way to work from home, your uncle averages only 20 miles per hour. So 20 there. On his way home, he averages 40 miles per hour. If the total time was 1.5 hours, how long did it take him to drive to work? Now, this is where it gets a little tricky because people have a hard time figuring out what the variables should be. Okay, I'm going to let T equal the time to work. So if his total time was 1.5 hours, no matter how long it took him to get to work, his total time has to be 1.5 hours minus how long it took him to get to work. If it takes me 4 hours to get to work and 2 hours to get home, so my total time is 6. Okay? If I want to know, okay, if I've traveled X number of feet, and I've got to go 15 feet, 15 minus X is going to be how many more feet I have to go. So my time to work is T. If my total time is 1.5, 1.5 minus T equals my time to home. Because I can't be more than an hour and a half. So T is here, 1.5 minus T is here. It has to be in that order because he has to go, an hour and a half is the longest amount of time he can travel. He takes the same route to work as home from work, so the distances will be equal. So if you really want to have some fun, you can say the distance is equal to 20t because it's distance equals rate times time. And here it's going to be 40 times 1.5 minus t. So you can either put in d as a big huge D across those two, or you can actually figure it out, distance equals rate times time. His time to work and his time home from work, his distance to work and his distance home from work are the same, so the distances are equal. So to work equals home from work. So the distance to work, 20t, has got to equal the distance home from work, 40 times 1.5 minus t. I just need to solve this equation now. Okay, so 20t equals 40 times 1.5 is 60 minus 40t. So So I'm going to add 40t over here to this side. I will add 40t over here to this side. And I get 60t equals 60. So if I divide by 60, obviously t equals 1. And it asked us, the question asked us, if you remember, how long did it take him to drive to work? And his time to work is t, so we have solved for it because t equals 1, and t equals the time to work, so it took him 1 hour. Which means it only took him 30 minutes to come home from work. Last question. 2 jets leave Dallas at the same time and fly in opposite directions. One is flying west at 50 miles, one is flying west 50 miles per hour faster than the other. After 2 hours, the jets are 2,500 miles apart. Find the speed for each jet. Okay, so we have a slower jet and a faster jet, so I'm going to call them slow and fast. That makes it easier. Distance, rate, time. 2 jets leave Dallas at the same time and fly in opposite directions. One is flying west 50 miles per hour faster than the other. And it says find the speed of each jet. So I'm going to let R equal the slow jet speed. So the faster jet speed, if he's going 50 miles per hour faster, is going to be R plus 50. That's going to be the faster jet. So this will be R, and this will be R plus 50. It says after 2 hours. So this one's traveling for 2 hours. This one's traveling for 2 hours. Both traveling for 2 hours. They are 2,500 miles apart. So the distance, okay, this one's going to be distance equals rate times time. So distance here is 2R, rate times time. Distance here is 2 times R plus 50. The distance for the slow jet plus the distance for the fast jet has to equal the total distance. Okay, so the slow jet's distance is 2R. The fast jet's distance is 2 parentheses R plus 50, and that has to equal 2,500. We're going to simplify this. 2R plus 2R plus 100 equals 2,500. We're going to solve this. 4R plus 100 equals 2,500. Subtract 100. 4R equals 2,400. Divide by 4. 2,400 divided by 4 is 600. So R equals 600. And R, if you remember, is the slower jet. Back up here. So my slow jet travels at 600 kilometers a mile. I gotta check that out. Miles per hour. Miles per hour. And then the fast jet is 50 miles per hour faster. So the fast jet travels at 650 miles per hour. If you set the tables up, these are actually simple problems to solve. They're much easier to solve than you would think because there's a strategy behind them.